Ask a search engine who wrote Hamlet, and it does perfectly fine, because your answer happens to share your words. But ask something where the passage that holds the answer uses none of your vocabulary, and classic keyword search quietly fails. It has no way to know that two different phrasings mean the same thing. Today we're breaking down the paper that taught retrieval to match on meaning instead of literal words, dense passage retrieval, and the elegantly simple idea that powers it. By the end, you'll see exactly why semantic search took over question answering. To feel why DPR mattered, put it next to the keyword approach it was built to beat. Classic search like BM25 matches exact words. When your question and the answer passage happen to share vocabulary, it works beautifully and fast. But paraphrase the question even slightly, or reach for a synonym the passage never mentions, and the relevant text simply never surfaces. The engine has no notion of meaning, only of overlapping tokens. DPR matches meaning instead. Because it compares learned vectors rather than literal tokens, it can pull back a passage that answers your question while sharing not a single keyword with it. That is the leap keyword search could never make, and it's what unlocked open domain question answering at scale. Let's trace a question through the system and watch how a match actually happens. Your question first goes through a dedicated question encoder, a BERT model trained just for queries. It compresses the whole question into a single dense vector, a compact point in meaning space that captures what you're really asking rather than the exact words you used. Separately, a second encoder handles passages. Every passage in the collection gets mapped to its own vector ahead of time and stored. So this expensive encoding step happens once, offline, not while you wait. At query time, the entire corpus is already sitting there as vectors, ready to be searched. Relevance is then just the dot product between the question vector and a passage vector. A bigger dot product means the two sit closer together in meaning space, which is a wonderfully cheap way to score a match. No extra network pass required at query time. Since every passage vector is pre-computed, answering reduces to a fast nearest neighbor lookup. The system grabs the passages whose vectors sit closest to the question and returns them as the top results. Strip it back, and three ideas carry the whole method. Dual encoders. DPR trains two separate BERT models, one for questions and one for passages, so each learns the representation best suited to its own side of the search. Contrastive training. It pulls a question and its correct passage together in vector space while pushing the wrong ones away, and adding hard negatives, tricky near misses that look relevant but are not, sharpens that boundary dramatically. Semantic match at speed. Because meaning drives the score and every passage vector is pre-computed, DPR finds keyword-free answers through a fast nearest neighbor lookup that scales cleanly to millions of documents without re-encoding anything on the fly. All right, let's lock in the essentials. DPR popularized neural semantic search for question answering from Karpyshyn and colleagues in 2020. Separate BERT encoders map questions and passages into vectors, and relevance is simply their dot product. Contrastive training with hard negatives pulls correct pairs together while pushing wrong passages apart. Matching on meaning lets it find answers that share no keywords, all through fast nearest neighbor search. Want more of these retrieval foundations made simple? Head over to standarity.com, where explainers like this one live. See you there.